Good morning, everyone. My name is Mohammed Ababa. I'm here to present our article on an early warning system for evaluating effects of medical treatment using machine learning approach. The authors are me, Mohammed Ababa, from Armament University, Faculty of Computing and Software Engineering, and Ozlem Aktash and Professor Suleiman Sevic from Dokuz Eylül University, Izmir, Turkey. This is done as part of a PhD or a requirement for a PhD graduation for myself, and I will be focusing on these pointers to be presented for this session. These are the main points that are discussed on the article, which I want to talk about, or I want to emphasize on. As an introduction, generally, recent advancement in big data and high performance computing, along with the advancement in machine learning and deep learning, are paving the way or becoming vital for precision medicine in general terms. These things, or the application of machine learning, AI in general, can be applied to different aspects of the healthcare industry, which might include performing diagnosis, personalized medicine, or conducting precautionary actions required to treat a certain type of diseases or patients in general terms. In order to get or use the advantage of this approach or these methodologies or techniques, there needs to be a data that we can use or we can tap into. So we can say that the healthcare industry is not data insufficient, or there is a huge amount of data that we can use, or a valuable amount of data that we can use, or that we can tap into to develop and implement AI systems that can be used to support the healthcare industry in different aspects, especially for intensive care unit patients. There needs to be monitoring, a day-to-day monitoring or daily administration of the patients regarding their health status. So, for this purpose, we can be able to come up with a certain type of system that can assist the healthcare professionals in general. That is the main intention of this article or this research in general terms, helping medical professionals or healthcare professionals make informed decision by providing analytical data or insights or hidden insights from the data that they have gathered on a day-to-day patient monitoring. So generally, the objective of the system, if it is implemented as a system or a tool, is to provide early warning of dangerous patient health status, or generally decline of patient status in general. In order to work on this research, we need to look into existing workers related to this field. However, we are unable to find similar or exactly similar researches that are conducted on this area for ICU patient monitoring. However, we have tried to see different articles or related workers that we can use or that we have used as an input to work on or to understand the overall idea behind developing such kind of systems, or the requirements that we need to look into so that we can be able to develop a system or come up with a model that can be used for assisting the healthcare professionals in their day-to-day activities or clinical routine practices in general. So for us, we try to see uh, articles or researches that are conducted on the area of general machine learning application in the healthcare. And we have tried to see cause-effect relationship research that are done on healthcare data. We were unable to find lots of researches actually on this field. So we have tried to see, or we tried to see different aspects regarding machine learning techniques or algorithms or models that can be applied or that we can apply in the healthcare industry. For instance, most of the articles that are discussed on this slide, plus on the article that we have provided or for publication, emphasize the importance of machine learning approach for the healthcare industry in general. Along with that, they discuss the use of electronic health records or the vitality of electronic health records for coming up with AI techniques, for instance, for cause and effect relationship analysis in general. So these are some of the articles that we have tried to review, which are documented on the article that we have provided, which we have used as an inputs and gather information that we need to proceed with the research that we intended. As Maria said, methods for any machine learning algorithm to be implemented, we need a data set. So for our case, we used a publicly available data set, which is from Medical Information Mart for Intensive Care Unit version 3, which we have used. The dataset contains more than 45,000 patient data, which is collected from a single tertiary hospital in Boston, Massachusetts by MIT, or Massachusetts Institute of Technology. And we cannot be able to perform overall analysis on the whole data set, so we have to select specific section or portion of the data. So for our case, we selected patients who stayed more than 30 days in the hospital. Once that is done, data cleaning and data pre-processing was conducted. The first thing that we did is remove variables with no variance, which means a single value that is measured for the whole hospital stay or ICU stay in general, since it cannot affect the overall outcome, which we will discuss the reason later. And missing values are imputed using most frequent strategy, since this is a patient-based system. If there are missing values, we impute them, or we fill them with the most frequent value from the patient's database. Then after that, for the algorithm not to be biased because of the magnitude of the values, we standardize the data by generally removing the mean and scale the observation into a unit variance in general. Once that is done, the data goes through a two-step process. This is the system or the method that we try to come up with. In the first step, the data goes through principal component analysis. Generally, principal component analysis is used for dimensionality reduction. However, we do not intend to use it for dimensionality reduction in this case. We only need to gather the loadings of the contributions of each variable during the analysis of the principal component analysis, so that they can be used to track changes or daily changes for the patient in general. So instead of using it for dimensionality reduction, we use it to analyze the changes or the daily changes for the patient. So the data for each patient will be grouped based on the date it is gathered, because every day multiple times data will be gathered from the same patient for different measurements for checking the status of the patient in general. So on the first step, the data goes through principal component analysis to capture daily changes for the patient, so that we can see whether there is a change based on the administration of a certain intervention. For instance, the doctor might have given the patient a certain type of prescription medicine or a certain type of therapy today, and gathered the data tomorrow, so that he or she can be able to see the effects of the treatment that is provided. So the changes that we will capture, that is our hypothesis, using principal component analysis, will be able to reveal that there is a change, a daily change, based on the data that was or that is gathered. So for instance, the doctor might have given a certain type of medicine 2 days ago, and then the next day he has to see the effect of the medicine. So the change can be captured using this principal component analysis method. Then after that, in the second step, we have to make sure that whether these changes happened randomly or by chance, or whether they are genuinely significant or not. So for that purpose, we used causal impact R package, which is developed by Google. Generally, it implements Bayesian structural networks to predict the effectiveness, or whether a certain type of change after a certain type of intervention happened due to by chance, or whether it is significantly genuine or not, so that the doctor can be able to see or know that this change happened due to the intervention that is provided for the patient. So for instance, this is sample patient monitoring for a single patient using principal component analysis. For instance, on the first day, the patient shows the highest change on promyelocytes. However, on the second day, which means on the first day that the patient has been administered with a certain type of medicine, so on the second day, this is changed to lipase, which means lipase is showing a change. So which means from this, the doctor can be able to decide whether the medicine or the prescription is working or not, or whether there is a new administration that needs to be conducted or not. The same thing is true for day 3 of the analysis. So for instance, the third column or this column shows the changes on the third day from the second date. This shows the changes from the first date that was the analysis conducted for. Then after this, we use causal impact arrow package to analyze the impact of the change, whether it happened for or due to by chance, or if they are genuinely happening or not. So this plot shows those effects, which is one of the outputs of the causal impact arrow package that is provided once you do the analysis on the change. So whether the effect is random or by chance, or whether it is genuinely significant or not. So after the treatment time period, it will create counterfactuals that might show what would have happened if the intervention was not conducted or applied on that patient. Then based on that, we will decide whether the changes are significant or not. Apart from the plots, the tool gives tabular information regarding the changes that happened between those consecutive dates or after or post intervention. For instance, in this case, the bold phase indicates the actual value that might have happened or that happened after the treatment time period. However, we are expecting a negative 0.1 value, in which we can see there is a difference. If we deduct these two values, the difference will be the red colored section, or the red colored value, which is 0.89, which is the actual effect that happened from the expected value. So the chance of this happening by chance is a posterior tail area probability of almost 0 in general, which means we can say that this change happened, or this change is significantly genuine. It didn't happen due to by chance or by irregularities in the data. In cases where the changes happened due to lots of missing values or short treatment time period, this method, or the Bayesian structural network, which is implemented in the causal impact arrow package, provides the answer as a bogus or unambiguous result. It will be reported as such. So from this we can see that the impacts of the changes can be evaluated using causal impact arrow package, so which means daily changes can be tracked using principal component analysis, and those changes or the impact of those changes will be analyzed using the causal arrow package, so that the doctor will feel confident that the changes happened are genuinely significant or not. Then based upon that, he or she will decide what to do next, or what to prescribe next, or what type of therapy to provide for the patient on the coming days. As a discussion, generally doctors use normal reference ranges to check whether a certain change is normal or not. However, in some cases, minor changes in the reference range along with other measurements may provide significant information on the status of the patient. So that's why we need to come up with these types of systems that can be used to track the changes for their genuinity on the patient's status. So we try to come up with a simple system or a simple tool that can be used for daily clinical routine practices. And we want to emphasize that we intended this tool as a supportive or an assistive tool, not as an autonomous system that can be used by the healthcare professionals in general. So this is all about my presentation on the title an early warning system for evaluating effects of medical treatment using machine learning. So if you have any question, you can forward them through my email or other means on WhatsApp or other communication means that you can use to communicate with me. Thank you.